Okay, number 19 is another problem where they're asking us to find a point on a curve, and in this case it's the function y equals natural log of x minus x, which you're not supposed to know what that looks like here, guys, but they gave it to you. So there's a point on that curve somewhere that's closest to the origin, and they've kind of done a pretty good job of showing you roughly where that point is in this diagram. That looks pretty realistic to me, but the point here is we don't know its exact coordinates. So we're going to generically call that the point xy, and we're trying to find the minimum possible distance between that and the origin here is 0, 0. So once again here, guys, the key to a problem like this, what I often call a floating dot problem right here, is that we are going to try to minimize that distance between right there, and we're going to need the distance formula in order to do that. But as far as step one goes, creating a parameter between x and y, the equation that they gave you here, the curve that this dot is located on, that is your parameter. The y coordinate at that point is equal to the natural log of your x coordinate minus that x coordinate itself. So the parameter is really given to you in a problem like this. Number two, what are we trying to optimize right here? We want the minimum possible distance between those 2 points, so we're going to set up the distance formula. It's the square root of, and here we go, the difference in your x coordinates. It doesn't matter which way you do it. I'm going to go x minus 0, which is just going to be x squared, and now I realize I made that radical way too big. So that's the x squared, and then plus, it would be your y coordinate, y minus 0. And that y value then is just going to be the natural log of x minus x. So that's like y minus 0 quantity squared as well. And we got that little bit of advice back on problem number 17. If you guys saw that video, that starts right here. It is equivalent and easier to minimize the square of the distance rather than the distance itself. So we're going to square both the left and the right side of this equation and get d squared equals, and now the radical on the right just disappears. So it's x squared plus, yeah, and we're going to leave this in parentheses here, natural log of x minus x quantity squared. Okay, so that's what we're trying to minimize. So now in step 3, we'll go ahead and we'll differentiate both sides of this equation with respect to x. So that left side is going to need a little implicit differentiation. That's going to be a 2d multiplied by the derivative of distance taken with respect to x. On the right side, this one is explicit differentiation. Everything's in terms of x's here. So the derivative of x squared is going to be a 2x. Oh boy, this is going to get interesting now. And then plus, all right, we've got a big messy quantity squared. So its derivative is going to be a 2 out in front multiplied by the same base, natural log of x minus x. Drop your power by 1, so we're to the first power now, and then multiplied by the derivative within. The derivative of natural log of x is 1 over x, minus the derivative of x is 1. Okay, so that's our derivative there, guys. And what we're going to do now is set that derivative equal to 0 and solve. Now, the first thing I would do here is divide both sides of this equation, I guess the way I have it written, all 3 parts of this equation, by 2d. And if I do that, that cancels, leaving us with just the derivative of d with respect to x is equal to, and then what happens at this point? Really, guys, we just end up with a 0 over there on the right-hand side. So we've got 2x plus 2 times the natural log of x minus x multiplied by 1 over x minus 1, and all of that is going to equal 0. And guys, I almost always tell you, try to do as much work as you can solving these equations by hand before you go to the calculator and just type that mess in. Well, you know what? This one is really, really difficult and nasty. I don't think there's much of anything that we could do there on our own. So I'm going to go right to the calculator here, and I'm going to try to solve that and try to get a sense for what our answer is going to be that way. So let me go over to the Inspire CAS, and we're going to go, let's see, for you guys it would be menu, and then it would be number 3, the algebra menu, and number 1, solve. So here we go. We're taking 2x and then plus 2, in parentheses now, times the natural log of x. Uh-oh. Where's the natural log on this calculator here? Ooh, that's a good question. And I wish I'd looked this up ahead. Oh, wait a minute. Natural log. Found it. Okay, so natural log of x. I got to use a parenthesis to close that x right there, and then a minus x. And we'll close that parenthesis there. That then gets multiplied by another set of parentheses, and it was going to be 1 over x, gotcha, and then minus 1. So we're going to close that parenthesis as well, and that's the end of the left side of the equation. So we want all of that to equal 0. We have to remember to put a comma after that, and we're going to tell this thing to solve for x. Now you got to remember, it is possible you might end up with multiple solutions to this equation. Let's see what happens when we hit enter. Okay, looks like we just got one. And if I go back and look at the diagram here, this value for x of 0.633 looks like it's in the ballpark right there of where we thought it might be. So I feel pretty good about that. So 0.633 is going to be our answer right here, 633. And just a little reminder then, guys, answer the question. Find a good numerical approximation to the coordinates of the point on that point, that curve right there. So we have found the x coordinate here to that point. So I'll go ahead and start in ordered pairs, 0.633, comma. And now we're going to go right back here to natural log of x minus x to figure out what that y coordinate is going to be. So we're going to type in the natural log of answer, that'd be natural log of x, and then minus the answer itself, natural log of x minus x, and that gives us, a y coordinate then. That looks a little strange right there, of negative 1.090. I'm going to assume that that's right. Again, that looks kind of reasonable right there. So let me write that down. Yeah, negative 1.090. Okay, and it looks like we've given them what they were asking for here, guys, which are the coordinates of that particular point on that goofy curve that they gave you there that was going to be as close as possible to the origin. So let me check that answer for number 19 before I shut this guy off. And what did we come up with right there? Yep, that is the right answer for that one. Okay, so that's a wrap on number 19.